Hi, everyone. Thank you so much for joining us for the EDK2 code, VSCODE extension for EDK2. We'll get started here in just a moment. Thank you. Thanks again for joining us for the UEFI Forum hosted EDK2 Code VS Code Extension for EDK2 webinar as part of the 2024 webinar series. I'll go ahead and introduce our presenter here. So we have Guillermo Palomino Sosa here today, who is a silicon firmware development engineer at Intel. And then I'll go ahead and pass it off to Willie to present.
Thank you, Sia. So, my name is Guillermo, and thank you everybody for joining. And I will talk about this Visual Studio Code extension that I developed, and I open source for the community, for the UEFI community and EDK2 community, to make use of it, because I think it will be very helpful for people to be more productive and understand a little better their source code, their source base. Um, I'm, I will jump into the topics here. So first, the motivation to make the extension is when I start working at UFI. I saw that the code base was a massive code base. So I was working in a previous company before Intel that we have work on small projects. We just 100 files in the source code, and then I jump into UFI source code base on the server side at Intel, where we have thousands and thousands of files and are related each other, and it's very difficult to for a new graduate to start learning and understanding how all those files connect together. uh, then I realized at some point that there were not a lot of tools to support some of the IDE features that you get in other frameworks. If you're working with JavaScript, you will get a lot of uh, tools, or you're working with Python or some of the Python framework, you will get a lot of tools to help you to understand the framework. And there was no such thing for UFI. There were some applications that tried to help people to understand the code base, and I try a couple of them, and I decide to take the better and the best of some of those applications and put it all together in an extension that more people can use together. So to install the extension is pretty simple. It works like any other extension in Visual Studio Code. You just go to the marketplace in the editor and search for EDK2 Code, and from there you can install the extension. The documentation for the extension and how to use it, you can find it here in this wiki page. It's also on the main page of the extension, and it will help you to understand a little bit some of the commands and functionality that the extension provide. I try to make most of the command and the functionality some kind of intuitive for the people, to even if they don't know that they are using the extension, so they can start using it without reading the documentation. But if you want to take a further step and take more advantage of the functionality of the extension, I would recommend for you to read some of the wiki page. The documentation is not always updated, so I encourage you, if you find some problems in the documentation, uh, to open a GitHub issue on the documentation so I can fix it, or you can contribute also to make the documentation better for everybody. Um, one thing important of the extension is how it works. So the extension can work in 4 different levels, depending on how your source code was compiled and how much time you want to invest on the indexing of the code. Um, it's not like it will take you a lot of time to have it fully configured, but sometimes you just want to open a folder and start looking at the code. So you can do that. That will be the first type of source index. That is the one at the bottom of the table. So it will parse the full workspace that you open just by opening a folder that you have with the EDK2 code. And and the last column is the user experience. That means the amount of commands and the amount of accuracy you will get from the extension if you just open the code. The second uh, way to use it is if you configure manually in the extension which one is going to be your DSC file, that you the main DSC file or the main DSC files, in case you have multiple compilation to start using the extension. And that means that you manually have to configure the DSC file and configure the injected defines in your compilation. Mm. The other is, once you have the tier one is get the build information from the build directory, and that means that once you have fully built your project, you can ask the extension to parse the build folder, and it will gather all the information that it needs to parse the source index without intervention of the user. It will go to the build folder, parse all the files that were generated, and will gather the information to get you the list of files that were compiled and allow you to use most of the commands and the functionality of the extension. And the best option is the one on the top, to get the build information but also get the compile information command enabled. This is a parameter in the EDK2 build command that I added in the middle of the last year. So we currently have the support for the build report, that is that -y in lowercase. But if you add the -y in uppercase compile info, what it does, it will, as part of the build process, it will generate a list of files with all the files that were compiled in your project, and it will generate the list of compile commands that your project used for the compilation. And the extension consumes those files. I made that change in the core in order for other people, if they want to use the same file and information to create more tools with those files, that they can use take advantage of that part of that is already in the compilation in the EDK2 build command. And that will give you the best experience, because as it will get all the compile information and the extra parameter list uh, that we're actually using the compilation, it will help the extension to understand a little bit better the code base. And here's a list of the features that the extension has. It will have a status bar to display which files are being used in the compilation, and I will show all of this in the demo. This is just an introduction for you guys to know what to expect. So it will get you an status bar for the files that were compiled, or if you're looking at a file that is not even compiled, you will know that. You can list all the libraries that were compiled and open them, or all the modules that were compiled also. You can rebuild the index from scratch or just update the index in case something was changed and you want to use the previous configuration. Also, it will add the support for the different EDK2 commands. So I added support for the INF, DSCs, etc. All the files. That means that it will have the highlighting for the syntax. It will show the outline tree. That this part is already been done by a couple of other extensions that I have seen, that they have the highlighting of the syntax highlighting and the outline of the file. But it will also add some uh, parsing of the source code in the ADK2 files to allow you to go to the definitions and get some up to completion elements in some part of the files. Also to get the library tree in the case of the INF files, so you can better have a visual representation of how your file is being compiled and how it is configured. The same for the DSC files. In the case of the C files, it provides a different call hierarchy command. What that means is that it will show you in the functions which functions are being called by that function, and it will give you the hierarchy of call, some kind of the call stack of the function. This overriding the native call hierarchy function of Visual Studio Code. And the reason for that is that Visual Studio Code will parse the full source tree that you have and will give you the call hierarchy even if those files were not compiled. So the extension is replacing that call hierarchy command in Visual Studio Code so that it can give you better and accurate results. It has also syntax highlighting for the BFR and a little bit of help on the ACPI commands, and I will show that in the demo. The benefits that I've seen people get and I have been getting from the extension is that it will improve the productivity because it will help you to understand quickly the code base and to understand what was compiled and what not, and which definitions were included in your file. It will help you also to navigate faster through your code. That will save a lot of time to people because you won't spend time looking the wrong files. That it happens to me a lot of the time. So it also I try to make it easy to use. The first version of the extension were a little bit hard to configure, and the commands were not too intuitive. So with the feedback of friends and colleagues that were using the extension, I tried to make it the most easy to use. And you will get real-time feedback on the modification of your files, so you can have better understanding of the code. So I will share my screen to provide some demo on how the extension works, and we continue from there. So here I'm making the demo in the EDK2 core. And the way that Visual Studio Code is that you right click and open the folder where you have your project. In this case, I'm only compiling here the emulator package and the OBMF package. So, but in the case that you have your own packages, you will need to open in a higher level your folder. So I have here an example that if you have a folder called My Project and there you have the EDK2 and then inside that folder you have your own packages, you will need to open at this level Visual Studio Code to get the more benefits of the extension. Uh, Currently, so I will make the demo. Currently only opening the EDK2 command. So when you open the extension, the only thing that you will see after you install the extension is that it will add this menu here. That this menu is used by the extension for different purpose depending on what you are doing, and currently it doesn't have anything here. So I will show you this demo just opening one of the files here. I open this INF file. If you see, it has the syntax highlighting of the INF file. Also, it has the outline of the file with the different elements of the file, what they have, and you can navigate through the elements in the outline, and then it will update in the syntax highlighting. One thing that the extension does, just by opening the file, is you can right click and go to the definition on different elements in the EDK2 file. For example, I can click on go to declaration, go to definition here, and it will open the C file that I was trying to see. So I can click all the files and open the definition. It works also for the package section. I can go to the definition of the package and we'll try to open. Currently, as I haven't parsed the source stream, it will make the best guess. So Samantha, can people see my screen? I'm not sure. Let me stop presenting my screen and open it again. Okay, I think you guys can see my screen now. So I can right click and open the definition I was mentioning. Okay, Samantha said that she can see my screen now. Uh, so the other thing that I was mentioning is that it is showing the libraries, and if I click in the definition of the libraries, it will try to make the best guess of the libraries. So for example, this entry point, there is only one instance of the library, but if I go to the definition of the debug lib, uh, it will search the whole workspace and will find all the INF that implement the debug lib. So it will give you all the possible implementation of the debug lib. And the same works for the other elements of the INF file. It will also work the auto completion. So if I press Control Space, it will show me the auto completion elements that I can use. I think it works also in the libraries at this point. So no, in the libraries it still won't work until I index my source code. So to get to the point where you parse the index of the source code, you need to open the command EDK2 rebuild index, and then you will need to open your build folder. So I will select the build folder here. The extension will parse the build folder, and you can choose in case you have multiple compilations in your project or a single compilation on your project. You can select many of them or just a single one. So in this case, for the demo, I'm going to select only the OBMF compilation. And down here, you will see in the status bar that is loading the cscope symbols. And also it start creating some of the files that the extension require. So it's pretty fast, the loading of the workspace. It already parsed the index of the extension. So with that, now the auto completion should work. So if I open here and press Control Space, you will see that now it will show some suggestions of libraries that can be used in this section of the INET file. And the way that this works is that the extension already parsed the DSC files that were used in compilation. So it's getting all the libraries that were defined in those DSC files, and it's giving you that list so you can autocomplete. It also works for the GUIDs, and if you see for the GUIDs, it not only show the GUIDs that you can use, it will show you which file contains the definition of that GUID. So in this case, it's only showing you GUIDs that are inside your DSC files that you have in your package. It also will work for the same for the PCDs, for the PPIs that you want to use. So if you cannot see an auto completion of the PPIs, probably because you are missing the DSC file that has your definition of your PPI or your PCD. The other thing that had is we have this command open library, and this will show all the libraries that were compiled, and you can start opening individual libraries, and this will only show things that were compiled in your project, so you won't be looking wrong files. At this point, it also contains uh, the open module that in this case will show you only models or drivers that were compiled, and also you can navigate through them and open and see uh, which models were compiled, or if you want to just open a source file, you have another command here to uh, just open EDK2 file. This will open all the files that were compiled in your project. The way that this works is when you parse the index, it will generate this EDK2 file in your source directory, and this one will have some of the files that are used by the extension. Uh, One important file is this CSCOPE files, that this one contains all the files that were used in your compilation. And this is generated by the build process of EDK2. It also contains these compile commands, and this contains all the C files that were compiled in your project, and will contain also the command that was used to build that file. So it means that it will have the libraries that were included in the compilation, and also some of the defines that were injected in your compilation of that particular file. This file is a standard that is used by many editors to understand a little bit better the source code. So you can use that file in other editors, and I will show you how Visual Studio Code use that file to give you some understanding of the on the code. Now let me open another file here, the DSC file. So this is the DSC file that I was using for the compilation. If you see down here, you will see that the status bar show me to which project this file belongs. In this case, it belongs to the OBMF file. If I have opened multiple compilation projects in the build directory, it will show me to which of those compilation the file that I'm looking belongs. One thing that you will see is it has the outline of the file and also the syntax highlighting. But if you see, it will also gray out some pieces of the code on the DSC file. The reason for this is that the extension can understand uh, the variables and resolve the conditions in the file in real time to show you which part of the source file were used in the compilation and which other parts were not used. In this case, for example, the book on serial was not defined in the compilation. And if I go here to source the book enable, this one was set to false. So that's why this part of the code is grayed out. I can go to the definition on that file and we'll jump to the place where the variable was defined. And if I change it to true and save the file, now you will see that this piece of the DSC file is now enabled, and you can see that on real time. So it will give you a good understanding on a bunch of parts. So if I just start scrolling to the file, you will see that a bunch of the pieces of the code were not compiled because the variables were not set in the value, and you can have a better understanding when you are debugging the DSC file and your compilation to know or understand your project better. The other thing, here in this file, you can go to the definition of the libraries. So if you select a library and just click then go to definition, or just with control and click, it will open those libraries, and also it will work for the models. If you select a model here, it will open that model, or if you select the override of some of the libraries of that model, it will open also those libraries. Uh, Another thing that I want to show you is I'm going to open this C file. So imagine you have this C file, open it, and you want to understand how that file was compiled. If you see down here, it shows you that it belongs to the OBMF package, but sometimes you won't know how that was compiled. So the way to use this one is you can open this reference tree. Um, it will use this sidebar that I was talking at the beginning, and what it shows you is that this C file was included in this INF file here in this section, and then this INF file was included in this DSC inc file, and then this file was included in the OBMF package DSC file in this part. So this is how your CPU lib C file was compiled, and what was the change of includes that allow this file to be compiled. If you see here, this file is included in the DSC inc file, but it's also included directly here in the OBMF package compilation. So it has to pass for the compilation for this one to be compiled. One important part that I was showing was this the status bar that shows uh, that shows the status of the file. So if I open a file that was not compiled, for example, this ARM crash dump DXC file, it will show me a warning here that this file was not used in the compilation that I selected. So this will give you an idea that you're looking at the wrong file when you're debugging or when you're running a search. So it will help you to don't waste time looking at the wrong files when you are debugging or trying to understand your source code. Mm, the other thing that the extension does is, let me close this one, it creates in your base folder this .ignore file. And first I showed you the cscope files with all the files that were used in compilation. So this .ignore file is the inverse of that file. So it will include all the EDK and C files that were not used in the compilation. And the reason for this file is that Visual Studio Code uses this ignore file. So you can ignore files when you are searching things with the search bar here in Visual Studio Code. So if you enable this button here, this will exclude files that are inside that ignore file. So for example, if I search for serial status code report here, it will only show me 7 results, well, 8 results in 6 different files. And all these files are files that were used in compilation, where I have here an example of a Visual Studio Code that doesn't have the extension installed. if you see, I'm looking for the same string, but in this case, it showed me 9 files and 11 results of the same because it's showing me files that were not used in compilation. Yes?
Lily, if you don't mind, I think some folks missed it. If you don't mind re-showing how you open the EDK2 folder in the beginning,
Sure.
I think that would be helpful for folks too.
Yes, so to open the EDK2 folder is just you just go to in this case, as I'm showing just content inside EDK2 folder, you will need to open the folder from here just with open with code, or you can just do it from the file menu here. If you go to open folder, then you will be able to open your EDK2 folder from here, and this will open the extension in the right folder. Mm, The next thing that I want to show you, and I have a couple of minutes to continue, is how this improves the C files. And here I'm opening a C file. One of the first things is, let me compare this one with the instance that doesn't have the extension. So here I'm opening the same file on both the white one is the Visual Studio Code that has the extension, and the black one doesn't have the extension. If you see, and you have seen, I think, a bunch of the time when you open a file in Visual Studio Code for DK2, you will see a lot of wibble lines here that show you that it doesn't find the right defines or the right includes of the file that you're looking. Those wibble lines as are false positives just because the extension cannot understand the code base. That makes this problem window useless because it will show problems all the time. So in this case, it's showing that it doesn't find this variable. But if you see in the extension that has indexed the code and has enabled the compile information, the problem window doesn't show any issue at this point. And if I hover over the variables, it will show me the right definition of those variables. Um, and currently, I'm showing only the white one because this one will have the information for the extension that I want to show. So this will make the problem window useful now because, for example, if I start typing something wrong here, um, it will start showing me that this file won't compile because I missed something here. So it will still will show me now real results in real time, and you won't have to wait until you end up your compilation to realize that you put a bad string here. This useful for this use for the parsing of the C files is something that the Visual Studio already has. The extension only helps you to configure properly. One thing here is that Visual Studio Code makes a static analysis of your code. For example, here I'm assigning um, a variable to this buffer, that this buffer is defined here, but it's only 250 from size. And if you don't see that the Visual Studio Code is analyzing immediately, you can run the code analysis on that file, and that will check for that static analysis that I mentioned. And this is saying that I'm assigning a variable to a buffer that will make a buffer overflow and will show me this warning here. So that is very useful for people to realize and catch some of the problems early in the compilation before you start compiling the code. The other thing I want to show you is this library tree. So if I use the first one that I showed you before was this show reference tree, and I will show you this show library tree. And this work only on the modules. This won't work on the libraries. And the reason for that is that the module will know which libraries we're using compilation. So this one is showing me all the libraries that were used in this compilation, but it will also, I can expand and know that this new library includes another two libraries, and this PI hub lib includes another three libraries, and so on and so on. So with this, you can see the chain of dependencies and how those libraries were included in your file, uh, in directly or indirectly, looking at this dependency tree. Also, one thing that now works because it knows how this file is compiled, I can go to the declaration of this debug lib, and it will jump to the exact point in the DSC file where this driver was getting the declaration of the debug lib. So if I look for the debug lib in this file, you will see that there are 20 instances of the debug lib references in the DSC file. But the extension, I checked the algorithm used by the DSC parsing in the build command. So I'm using the same algorithm to determine which of the libraries was the one that it was included in your compilation. So with this one, you can see which version of the debug lib was included. You can modify this one if you want to change the version of the debug lib. Also, you can go directly to the definition of the INF file, and we jump to the INF file of the debug lib that was using. Uh, Now, the last thing I want to show you here is the support for the ACPI. So here in the ACPI, you will see that also the outline is being shown, also as the syntax highlighting. But one thing that I added, and this was because when I was working on some ACPI files, I saw that the documentation is huge. So sometimes you were jumping between the documentation and the source file to understand a little bit what the source file was doing. Here in the extension, I embedded the documentation for some of the symbols in ACPI, so you can just hover on some of the keywords in the ACPI file, and this will show you the documentation for that file. This is currently based on ACPI 6.3, and I make a parsing of the PDF, so you will see some weird characters here, but I already got access to uh, to the ACPI documentation source file, so I will include the most recent some of the files that were uh, some of the most recent documentation here. It will also have some auto completion for ACPI symbols along with the documentation. So in case you want to edit the file, you can see some of the keywords auto completion here in the file. This one doesn't have the problem checking or some of the more advanced features. But anyway, it will make some help for the people that are editing the files. So with this one, I will jump to the question in the chat window. And the first question is how to people can contribute to the project. So this project is already open source in the in GitHub. So you can either fork the source code of the extension and make some improvements for the extension, or just by opening some issues and problems that you find in the extension and open the GitHub issue. That will be very helpful for other people to see the questions of the issue in GitHub and how those get resolved. For me or the people that are making changes in the extension to fix those issues in the extension. Uh, the next question is, will it detect a buffer overflow during the definition? So this one, the static analysis is using CLang. And this one is already inside the Visual Studio Code. The static analysis is not part of the extension. What the extension does is only enables Visual Studio Code to understand the code base so it can run that static analysis better. So I think the static analysis of CLAN will detect some buffer overflows, but just the static one. It won't execute or run some dynamic analysis on the code. So it is a little bit limited on what CLAN can do. The next question is the ASL parser. Does it support include? This one does not support the include statement. In this case, I don't have any include. But if this is a feature that you think is valuable for your day-to-day job, you can open an issue in the GitHub page, and you can suggest how the feature should work. So it will help me to understand the needs of people outside Intel, how they use the extension, and I can implement some of the feature requests. Or if you're interested in develop the source code of the extension, I can I can explain how you can implement that feature in the case that you want to implement the feature, or you can wait for me for implement some of those features. The following question is, does this extension works on all operating systems? I have tested the extension on Linux and Windows. For Linux, there is an extra step you have to make, and that is install manually cscope. For Windows, the extension has an embedded instance of cscope, but it's pretty easy to install and make it run on Linux. I put an example here on Ubuntu. You just will need to install cscope. But if you have your cscope installation in a different path that is not global available, there is a setting in the extension for you to override uh, the cscope command that is used inside the extension. So you can open this setting in Visual Studio Code and just override the command. Uh, so is the EDK2. I cannot see here the settings right now. But yeah, it will work in different noises. I haven't tested in macOS just, but I will guess it should be working also in macOS. Uh, the other question is it true that the extension doesn't support compiling the UEFI code? Yeah, currently the extension doesn't have any command to compile individual files. Um, I haven't. The reason for that is I've been developing the features of the extension based on the needs that I've been having and the needs that the people that is using the extension is been having. So now no one has asked me to the ability to compile individual files. So that's why I haven't invest much time adding that feature. But if that is something that the people outside and the community thinks that is useful, they can open a GitHub issue. We can work to add some of those features. And the last question in the chat is, are there plans to port the extension to other editors? Currently, the implementation of the extension is using a lot of the Visual Studio Code APIs directly. So it will be hard to port the extension to different editors for now. One of the plans that I will have in the future, or if someone has some time and wants to contribute, is to change the architecture of the extension so it can be reused by other editors. But currently, my decision to make it on Visual Studio Code is and some so binded to Visual Studio Code APIs was because I saw a bunch of people is using that editor, so more people will be able to use it and make it binded to Visual Studio Code APIs, accelerate the development of the extension. So it was easier and faster to make for something that is useful to the much majority of the people. But if other people are comfortable with other editors, uh, some of the plans would be in the long future to port the extension to different editors, but it will need support for of more people that are more used to other editors. For now, I'm only using Visual Studio Code, and I think most of the people is using, but I understand that there is a lot of people that are more used to different editors.
Great. Thank you so much, Willie. And thank you everyone for joining us here today for this webinar. So just as a note here, the next part of this webinar, if folks are interested in joining us, we'll have a live interactive Q&A on WebEx. And this will be an opportunity to speak directly with Willie and ask him any additional questions that you have. So again, thank you all so much for joining this webinar today. The slides will be available on the UEFI Forum website, and the video recording will be available both on Bright Talk and on the UEFI Forum YouTube channel. Thank you all.
Thank you.